So in this video, we want to find the area under the standard normal curve that lies to the left of z equals 1.46, to the right of z equals negative 2.14, between z equals 0.48 and z equals 1.97, and to the left of z equals negative 1.25, or to the right of z equals 1.64. Now we've done this problem previously using the tables from the appendix of the book. In this video, I want to show you how we can use the calculator to find these areas. Okay? So the command that we're going to use on the calculator is called the normal CDF command. Okay? And the way the normal CDF command works is we're going to enter a left bound followed by a right bound, followed by the mean, which for the standard normal distribution is 0, and followed by the standard deviation, which for the standard normal distribution is 1. So our command's going to look like this, okay? So I'm going to actually begin by looking at C, okay? So if we look at C, we're going to have normal CDF. Our left bound is going to be 0.48. Our right bound is going to be 1.97 with a mean of 0 and a standard deviation of 1. Okay? So this is going to give us the area between 0.48 and 1.97. So again, between our left bound and our right bound. So if I bring in my calculator, so here's the calculator. To find the normal CDF command, that is going to be under this button here, the VARS button. The second of the VARS button is the distribution button. So we're going to go to second distribution, and that's going to give us a lot of different distributions that we'll be using throughout the course. In fact, we've previously used the binomial PDF and the binomial CDF commands. Now we're going to be using the normal commands. Okay? Now what we're going to be using is this CDF command. So it's number 2 here. So I'm going to select that. Now on the newer calculators like I have here, when I select that, it gives me this window, and I'm supposed to enter the lower bound and the upper bound. So my lower bound is 0.48 and my upper bound is 1.97. My mean is 0 and my standard deviation is 1. And so I'm going to paste that. Okay? Now, so I get this that I mentioned before, how this was going to look. I get that on the screen of my calculator. If you have an older version of the calculator, then you would have to actually type it in right here. Okay? You wouldn't get the window to fill in like I did. When I hit enter, I get 0.2912 if we round to 4 places. Okay? So this area between negative 0.48 and 1.97 is 0.2912 when rounded to 4 places. Okay? Now I started with C because we literally had a left bound and a right bound. For the other problems, we don't. So if we look at part A again, we're finding the area to the left of 1.46. So picture-wise, here is 1.46, and we're looking for this area. Okay? Well, the trouble is that I don't have a left bound. Okay? You know, like over here with the 0.48, that was a left bound, 1.97 was a right bound. Here I don't really have a left bound. That area goes forever to the left. I only have a right bound. So when this happens, we just use a really large negative number as our left bound. Okay? So we're going to use the command normal CDF. Okay? We're going to use a really big negative number. So I use negative 10 to the 99th power for that. And then we're going to put our right bound, 1.46, and our mean of 0 and our standard deviation of 1. Okay? So if I go back to distribution, normal CDF, in this case my lower bound, my left bound is going to be negative 10 to the 99th power, and my upper bound is 1.46. My mean is 0, my standard deviation is 1. So again, here's that command, and so I get 0.9279 if we round to 4 places. So 0.9279 is our area. Now notice in both of these cases so far, these are the same results that we obtained when we did it by hand. Let's look at part B. Okay, so part B, we want to find the area to the right of negative 2.14. So negative 2.14 is here. We're looking for this area. Well, in this case, we don't have a right bound. We have a left bound, but we don't have a right bound. So we're going to do the same kind of thing. Our command is going to be normal CDF, where we have a left bound of negative 2.14. We don't have a right bound, so for the right bound in this kind of circumstance, we're just going to use a really big positive number, and so I like to use 10 to the 99th power. And again, our mean is 0 and our standard deviation is 1. So bringing in the calculator again. So second distribution, normal CDF. Our left bound is negative 2.14. Our right bound is 10 to the 99th power. Our mean and standard deviation are 0 and 1. So if I paste, I get a result of 0.9838 when rounding to 4 places. So 0.9838 is that area. Okay? And last but not least, we need to do part D. So we'll do that on a different sheet. So in part D, again, picture-wise, we're looking for the area to the left of negative 1.25 or to the right of 1.64. Okay? And so there's no direct way to find this on the calculator. So what we'll have to do is we'll have to find this and add them together. Or we could find the area in between and subtract from 1. Okay? So we could do that either way. So to find this area here, we would do normal CDF. We don't have a left bound, so we would use a big negative number to negative 1.25 with a mean of 0 and a standard deviation of 1. That's going to give us the area to the left of negative 1.25. And then if I do normal CDF, 1.64 to a big positive number with a mean of 0 and a standard deviation of 1. That's going to give us the area to the right. Okay, so let's do each of those. So normal CDF, big negative number to negative 1.25, mean of 0, standard deviation of 1. So that area is about 0.1056. Okay. Finding the other, normal CDF. So we're going 1.64 to a big positive number. And so that is 0.0505. And if we add those two things together, adding those together, we're going to get 0.1561 for the area. Okay? The other possibility that we could do to find this area is we could have found the area in between and subtracted from 1. So we could find normal CDF. We could find the area between negative 1.25 and 1.64 with a mean of 0 and a standard deviation of 1. Again, this would be our left bound and this would be our right bound for the area in between. So if we do that, negative 1.25 to 1.64. And so that is 0.8438. And so if we do 1 minus that, 1 minus 0.8438, we get 0.1562. Now notice we get a slight discrepancy between our two answers, and that was because of my rounding here. So had I not rounded here and carried the decimal out more places than to 4 places, I would have been more accurate, which would have been the better thing to do. In our next video, I'm going to show you how to use StatCrunch to find these same areas.